This recording is about gravitation and planetary motion. The way this particular software works here is physics simulation software is that by default it's that there's gravity pointing down, and that's what it says. You're vertical, so if I just hit the run button, that's out of the picture here, then everything is just going to fall down. So I have to change the way gravity works in the software. So I changed it to planetary. And this is not the typical gravitational constant, which is really, really small, 10 to the negative 11, but I changed it to a value of apparently 40 because that works really well in the software with the time given in the software, because otherwise it would take years in order for just one orbit here. Okay, anyway, so that's the way it looks like. And so I hit OK on this one, and then I hit the run button, and if we just leave these two here, then they will attract each other gravitationally and slam into each other. Notice that I made these blue here as if it was the Earth and gray as if it was the Moon. You notice that the Moon apparently accelerates faster towards Earth. The force on the two is actually the same, but the acceleration on the Moon is much larger, and that is because the mass of the Moon is much smaller. I gave it here 0.003 kilograms. Again, I made these. I just made up these masses, these numbers here, so that it works pretty well in the simulation here and doesn't take too long. I don't have to fiddle around it too much. Apparently, the mass of the Earth is 0.3 kilograms, so 100 times as much, and that's what you saw is happening. That the Moon, because of its smaller mass, is accelerated easily towards Earth, while the Earth moved just a little bit. Okay, let's go back to the Moon and actually do give it some speed, some velocity to the left here, because without it, they will just slam into each other. And now that combined with the gravitation, I hit the run button, produces the orbit, because what's happening here is that the Moon starts moving this way, but then it's gravitationally attracted to the Earth, moves this way, gravitationally attracted, and that changes the direction, and it also changes the velocity vector just as you go into a curve, and the friction between the tires and the road changes your direction and giving you a centripetal force. In this case, that would be the Moon orbiting the Earth. Okay, I'm going to hit the reset button, and let's just change a few things. For example, I'm going to put more mass on the Earth. So instead of 0.3, I may have 0.6 kilograms. And the Moon is still orbiting, but in a tighter orbit, because now the gravitational force is larger. So I may increase the Earth's mass even more. There we go, and an even tighter orbit, but it's still orbiting. By the way, though, I kind of forgot here a moment ago. Let me go back to 0.3. You saw it, but I forgot to point it out, that it's not only the Moon orbiting the Earth, but it's the Earth also orbiting, kind of making this wobble here, because it's attracted with the same force towards the Moon. It's just that its little wobble or orbit is not as much as the Moon's is, because it has quite a bit more mass, 100 times in this case, the way I set the numbers. Okay, so more mass produces that. What about less mass? Okay, what about if we decrease the mass? So I'm going to use 0.2 for example. Let's see what happens to the Moon. And sure enough, it makes a bigger orbit. In this case, actually, I believe the Moon, as it went out of the picture, could possibly be lost. I didn't check that out before. I'll see in just a moment if it does come back, because in this case maybe the tangential velocity was too large that the gravitation of the Earth wasn't able to hold it back. So I think that's what happens, because I don't see it coming back. So apparently in this case, let's not make this too small. There we go. And there, sure enough, the orbit is larger, because there is less gravitational force between the two, but it's still in orbit. So the scenario I showed a moment ago actually described escape velocity. Now the Moon is not going to do that, but in order to get so to say, away from Earth, not from its gravity, but to keep on going in space. Earth's gravity is still slowing it down, but not sufficiently. There is such a thing as escape velocity, that if it's large enough, you're not going to orbit the Earth anymore, but you're going further out. You're still being slowed down by it, but you can keep going out. Okay, let's see. One more thing, and that is, I'm going to put this back to point 3. And we're back to our typical orbit. And alright, hit the reset button. Okay, now what happens if I introduce perhaps something like a black hole? I'll make it black. There we go. And I take this one out. And I put this one here. In the middle, so there's my black hole of the same mass. So 0.3 kilograms. Hypothetical question, what if the Earth turned into a black hole? Well, of the same mass, that is. Well, apparently it's the same mass, so the gravitational force is the same, so the acceleration on the moon is the same, so therefore nothing on its orbit would have changed. And indeed that is the case. Oh, whoops. Okay, what did I do wrong? Oh, I know what I did wrong. I put that Earth out of the picture, and that actually attracted both of them, so I have to delete that actually. Alright, here we go. Here we go. So, because of the black hole sitting there, orbiting the moon actually a little bit as well, nothing of the orbit has changed, because the mass is the same, force is the same, and therefore acceleration is the same, and orbit is the same.